Wasabi, you guys, Silver here. Welcome to part 7, where we start doing some very, very tricky integrals. And this is just literally about strategies, pretty much just a bunch of integrals thrown at us. So I'm going to go over these strategic wildcard integrals. I might have to split this in 2 parts because there are a lot of integrals. So a lot. Well, there's 40, but 20 is already like an hour. So let's go ahead and get started into strategizing. Again, this is just basic substitution. Don't let scary constants intimidate you. It's just a constant. So just let u equal x plus 1. This is just u square root of 2 du. So the answer is just x plus 1 to the power of root 2 plus 1 over square root of 2 plus 1 plus c. And that's all you have to do. Don't let constants scare you. This is very weird. Even though it's in terms of sine and cosine, it's still pretty awkward. So here we can actually use sine of x and then use sine square into 1 minus cosine square, right? We have cosine at the bottom. Oh, would you look at that? We can let u equal cosine of x. And then don't forget that du is negative sine of x. So it takes care of the sine of x, but we will have a negative. So we'll have negative 1 minus u square over u. We can technically take that negative in, make it u square minus 1 over u, which gives us u minus 1 over u du. Cool. So then the answer would just be cosine square over 2 minus the ln of cosine x plus c. For this one, let's see. This looks very weird. You might think of partial fractions, but this is a linear function. What we can do is we can do a force U-substitution. So let u equal 2x plus 1. And then for x, note that x is equal to u minus 1 over 2. And then, of course, du is just 2 dx. So we'll have to have a half. And then for the bounds, if we plug in 0, we get 1. Plug in 1, we get 3. Okay. X is equal to u minus 1 over 2. And then we have du over u square. Okay. 1/4 from 1 to 3. And then u minus 1 divided by u square. This, you can just simplify this as 1 over u minus 1 over u square. And we see that this is equal to 1/4 of the ln of u plus 1 over u from 1 to 3. Okay, we go ahead and plug it in. Plug in 3, we get ln of 3 over 1/3 minus ln of 1, that's 0, plus 1, so that's minus 1 right there. You can technically just leave your answer like this. You can simplify it if you want to, but if I'm competing against someone, I just leave my answer like this. This looks weird, right? But again, like I said, you have to sort of remember your derivatives, those 10 derivatives that I showed you. Here, so this is an x cube, right? We know that u is equal to 1 over x, and that du is equal to negative 1 over x squared. But here we have x cubed, so what we can do with this is this can be split in x and x squared, right? So what we technically have is cosine of 1 over x, x squared times 1 over x, right? So when we do our U-substitution, this becomes negative cosine of u times u du. And you notice this is an integration by parts, an integral. Alright, let's go ahead and do that. Let negative u here, we have cosine, this is 1 to 0, sine, negative cosine. Okay, so I see that we have negative u sine of u and then minus cosine of u, which is now negative sine of 1 over x over x minus cosine of 1 over x plus c. Here I know that the integral of secant x tangent x is secant x, so it would be easier to do integration by parts by doing that, right? Okay, so this is secant x, this is negative 1. We can actually keep going, we can go further, right? The integral of secant x, that's just ln of secant x plus tangent x. So now we go like this, and now our answer is just straight up x secant x minus the ln of secant x plus tangent x. And that's our answer. Very quick, very fast. Alright, here I think this was also part of the integrals to memorize, because this is just common. This is the same thing. If you know your algebra, it's just the same thing as this. So of course the answer is just this highest peak here, e to the x plus c. That's it. You could do U-substitution, but again, it's just this is just very common in integration B. Alright, inverse tangent and then a square root of x here. So what do we do? Well, this looks like a composite function, so of course we do U-substitution, but we don't have, you know, when we do our du, this would be 1 over 2 root x, but we don't have that. So what do? Then we do a force U-substitution. Alright, so let's do a force U-sub. Solve for x, and then 2u du equals dx, so we derive both sides. Okay, got it. This is, let's see, 2u, I'm going to do 2u first, and then inverse tangent of u du. Okay, cool. This is an integration by parts problem, right? You would think, okay, we could just easily derive this, but then you would have to integrate inverse tangent. So let's derive inverse tangent. We have 2u here, then we get u squared here, and this would become 1 plus u squared here, minus. Okay, so then this is equal to u squared of inverse tangent of u minus the integral of u squared over 1 plus u squared. Okay, I can make this is very similar to the denominator, right? Then I think it would be nice to do a zero substitution so that it cancels out. So what I mean by that is we would go ahead, let me actually fix that too. So I would do plus 1 minus 1 so that this cancels out, right? So then that it will give us 1 minus 1 over 1 plus u squared. Now it's a much easier integral. Cool. So now this is equal, if I make more room, this is now equal to u squared inverse tangent of u minus u plus inverse tangent of u. So now that makes us, let's see, we remember that u is equal to square root of x, so u squared is x, inverse tangent of square root of x minus square root of x plus inverse tangent of square root of x plus c. Well, it's just an ln here, we would have to do integration by parts and derive ln x squared plus 1. But then we would have to integrate 1 here. Okay, then this is going to be x squared plus 1, 2x, and this is going to be x. So we see that this is equal to x ln x squared plus 1 minus 2 of x squared plus 1 dx. It's the same mini integral that we dealt with, right? Plus 1 minus 1. Do a zero substitution, and then it would be easier. So just to go by this fast, this is now the total answer is this. I can just do parentheses so that I don't lose my track. And then you can leave your answer like this. Just like that. Ooh, what do we do here? E squared. Okay, that's just a constant. Just a constant. So without hesitation, it's just x e squared plus c. It's just a constant. Just a constant. Oh God. To the power of 4. Jesus, Pascal's triangle? I mean, you could do that if you're brave enough. Or we can do a forced U-substitution. So let's do that. A forced U-substitution. Let u equal 1 plus the square root of x. So we have to solve for x. U minus 1 square is equal to x. Then the derivative going to be 2 u minus 1 du. Okay, we'll go ahead and apply that. This is u to the power of 4, and then we have 2 u minus 1 du. Cool. Okay, this is a lot better because I could just distribute this u4, right? So now I could just go u5 here minus u4 here du. Okay, so then this is equal to 2, and then we have 1 plus square root of x, 6 over 6, and then minus, then we do the same process. Right, it's just basic EU substitution here. To the power of 5 over 5. Plus c. And that's it. You can just leave your answer like that. So what do we do with this? So we need to take care of this x, right? I don't really care about this constant. Constants are just constants. But we really do need to take care of that x though. So we have 12x. Okay, 12x. We can make it into similar to the denominator, right? So our denominator is 3x plus 1, right? I want this in a way to cancel out 1 plus 3x. We have 12x. Notice that when we have 3x plus 1, and we multiply it by 4, we get 12x plus 4. So I would like a plus 4 so that this cancels out, and then we're left with the 4, right? So, okay. Then let's add a 4. Plus 4 minus 4. Alright, zero substitution. Then we're left with 12x plus 4, which we can factor 3x plus 1, right? So that we purposely cancel it out. And then our leftover, we have minus 4 plus 1. That's negative 3, right? Minus 3, 1 plus 3x. Okay? dx. Cool. So then this is just 4x minus, and then that 3x plus 1. So that 3 cancels out with this 3 when we do U-substitution, right? When you let u equal 3x plus 1, then du is equal to 3. That 3 becomes 1/3 to the other side, and so that 1/3 will cancel out with this 3. I'm going very fast. So again, you should probably already know this, right? When we do a U-substitution, it cancels out. Okay. Anyways, we should have already know that. So this is ln 3x plus 1 plus c. And there we go, and that's our answer. So very fast. Again, zero substitution. You gotta get used to that. Here, again, same thing as 1 plus e to the x, right? We want to make this, I want to make it similar to the denominator, right? So I want plus e to the x, but then I have to do a zero substitution minus e to the x. This is okay because here it's just a u substitution. So that's perfect for me, right? Let u equal 1 plus e to the x, then du is going to take care of that e to the x. Okay, awesome. So then this whole thing cancels out, just like how I wanted. All right, so then this is the answer is just x minus ln of e to the x plus 1 plus c. All right, zero substitution, very, very useful, powerful for beginners. You just got to get used to it. Holy hell, what do we do here? What do we do here? So what I would do is I would split it. I would actually go ahead and split this, right? We have 1 plus cosine here, and then we have sine 1 plus cosine here. This is just a basic u substitution. So this is fine with me. Here we need to take care of this. So let me go ahead and solve this first, right? You know, let u equal 1 plus cosine of x, then du is negative sine. So this becomes negative ln of 1 plus cosine of x, right? But then we have 1 plus cosine of x. What I want to do is with this integral, I want to do conjugate, right? I want to conjugate, so that now this becomes 1 minus cosine square, which equals to sine square. Okay, so let me just erase this whole bottom portion here. Right, so with that, this now becomes 1 minus cosine of x sine square here, which is now equal to cosecant square of x minus cotangent x cosecant x. Right, and we know this, these standard integrals. So okay, then we could just go ahead and straight up answer this. Okay, so this is just cosecant x minus cotangent x minus the ln of 1 plus cosine of x plus c. And that's it. Here I'm going to go ahead and conjugate, and what I mean by that is I'm going to go ahead multiply this by 1 plus x and multiply this by 1 plus x. And what this does is this gives me 1 plus x over 1 minus x squared. I like this because I can just split it, right? If I split it, this is just inverse sine. And then on the other term, this is just a u substitution. It's just a u substitution. Perfect. So then this is just equal to inverse sine of x minus square root of 1 minus x squared. Just by using u substitution, right? You let u equal 1 minus x squared, right? So This becomes our answer, and we're done. Right? That simple conjugation really helped us. All right, what do we do? Integration by parts, trig manipulation. Very good. This is symmetry. Negative pi over 2 to pi over 2. We have these very sussy bounds. Alright, this is an odd function because this is even, and then this is odd. So this whole thing is an odd function. So the whole answer to this integral, it's just 0. There's a bunch of secant x's. Oh, but look, we have secant x tangent x. We know that the derivative of secant x is secant x tangent x. Cool, so we'll let u equal secant x. Then this will give us du of u squared minus u. This is equal to, we can factor this to u minus 1 du. We have 1 here. Zero substitution, because I see this lonely u here that I can take advantage of. So I want to cancel out u minus 1 because I have this 1. So then I could do 1 minus u. It's just going to give me a negative 1 constant, so I don't mind that. So negative u minus u plus u, right? Zero substitution. And this is okay because this cancels out and this cancels out. So we end up having 1 over u plus 1 over u minus 1 du. And now this gives us ln of u, which is secant of x, plus the ln of u minus 1, which is secant x minus 1. And that is our answer. This seems like integration by parts because I can derive inverse tangent and I can integrate 1 over x squared. It's not x squared, 1 over x squared. Okay? So, deriving inverse tangent, integrating 1 over x squared. Okay? It's not x squared, 1 over x squared. So be very careful with that. So now this is just 1 over 1 plus x squared. And then this is negative 1 over x. Okay. So now this is just equal to negative inverse tangent of x over x plus the integral of x 1 plus x squared over 1 dx. Uh-oh. What do we do with this integral? Yep, we do a zero substitution so that we can do a bunch of cancellations here. So we're going to do plus x squared minus x squared, right? And then this will cancel out, and then this will cancel out with this, right? And that's going to be okay because then we're left off with this U-Substitution. So that's all right. Cool. So then we end up getting 1 over x minus x over x squared plus 1, right? Cool. So then our whole answer is just negative inverse tangent of x over x plus ln of x minus a half of ln of x squared plus 1. And we're done. Ooh, this one's a very common integral in integration B. Very common integral. So, to see this, it's actually very sneaky. It's a very sneaky integral. Note that the derivative of x 3/2, the derivative is 3/2 of x to the power of 1/2. Okay, this is equal to 3/2 of the square root of x. So we have a square root of x here. Alright, cool. So, but x to the power of 3/2, where is that at? It's actually hidden like this. X 3/2 squared. Very sneaky, very hard to see. So we could go ahead and let u equal x to the power of 3/2, and then we get, let's see, so it'll be 2/3 because we have to reciprocate to the du. So the du will take care of the square root of x here, and then we have 1 plus u squared. This is just inverse tangent, so the answer is 2/3 inverse tangent of u, which is x to the power of 3/2 plus u. Okay, this is probably, because this is a very common integral that shows up in integration B, it's very good to memorize this process, the trick to this. Okay, very sneaky trick. What do we do here? That looks very weird, right? We can let u equal, 1 plus e to the x, but then we don't have an e to the x, so it's we don't know where to go. What do we even do? We could do a force U-substitution, so maybe let u equal 1 plus e to the x, right? But then you would have to solve for x, and it would be, it'll be a hassle. However, there's also a this is kind of a sneaky way to see this, but if you let du, if you just derive it, you get e to the x dx, right? So what is e to the x? E to the x is u minus 1, right? So this is technically u minus 1 dx. So your du is 1 over u minus 1 dx, right? But then here we get square root of u minus 1 du. Does that actually help? Not really, right? It doesn't really help us. And like even if you let w equal u minus 1, then you end up with w plus 1 over w, and this still doesn't really help, right? So what do? What I do is another sort of, I guess, a better force U-substitution. Okay, in this type of force U-substitution, you let u equal everything. Okay, you let u equal everything, and I do this whenever all I see is just a radical, just a square root covering everything, right? So if it's just the square root and then a bunch of whatever function is inside, right, and it's like complicated, then I let u equal the whole thing. I let u equal the whole thing, right? And I'm going to show you why I do this with square roots. The reason is because the derivative of a square root of a function, a square rooted function, right? This is equal to 2 square root of a function, and then of course chain rule, f prime of x, right? We have this and this, they're both the same thing. So when we apply it in a U-substitution, u equals square root of 1 plus e to the x, then du is equal to, and then square root of 1 plus e to the x. Oh, that's just u. This is just u. And then we have e to the x here. Well, what is e to the x? Oh, e to the x? That's no problem. E to the x is equal to u squared minus 1. So we just plug that in as well. So what we have is we have 2u over u squared minus 1 du equal to dx. And we can just plug that in. So now we have u, this whole integral, u, and then 2u over u squared minus 1 du. Okay. So now we're really forcing a U sub here, just by letting U equal everything. Okay. So now this is just 2 U square over U square minus 1. Very similar, just different because this is a minus now. Okay. But we still apply the zero substitution. Minus 1 plus 1. Just to make it similar to the denominator, so that now I can go ahead purposely cancel it out, right? And we're left with 1 plus 1 over U squared minus 1, right? And so now this is just, basic integration. This is now 2U minus, okay, this is a negative inverse tanh. So it's minus 2 inverse tanh of U. So now we have 2, U is equal square root of 1 plus e to the x minus 2 inverse tanh of the square root of 1 plus e to the x plus c. Okay. Alright, I'll let this be the last integral because this is the 20th integral. We have x to the power of 5 e to the negative x cubed dx. Of course, you're probably thinking integration by parts, but can you really integrate this? I don't think so, right? So, what do you think? Well, we can let u equal x cubed, right? But then du is equal to 3x squared. Oh, but wait, but this is x5. x5 can be in terms of x cubed, x squared, right? Or if you want to look at it in a different way, you see how u is equal to x cubed? Then if I multiply u to both sides, I get u du. And then x cubed multiplied here, we get 3x5. That's also another way to look at it, right? Okay, now we really have x5 here. Du is going to take care of that. Cool. So now we have 1/3 of the integral. Don't forget, it's u du now. So this is u du e to the negative u. Okay, cool. So now this is equal to, well, just to be safe, you could just go ahead and go into integration by parts. E to negative u, negative, positive. Okay. This is 1/3 of u, e to the negative u, negative u minus 1, right? So now this is equal to 1/3 e to the negative u. U is equal to x cubed. And then we have negative x cubed minus 1 plus c. And you're done. So that's all the first 20 integrals. That is it for part 1. The second part will be made in the next video. So again, the same topic, just strategic integrals just to deal with. So yeah, so we'll keep on practicing with those. So thank you guys so much for watching, and I'll see you guys in the next video.